Now in the previous video we have seen what the linear differential equation is. What are the types of the linear differential equation? Now let's understand the concept taking an example. Now the example, if you observe, it is sin 2x dy by dx equal to y plus tan x. Now how to identify whether a question belongs to a particular type of the linear differential equation? As I have said, do not try to memorize linear differential equation. Using the types, identify a linear differential equation based on its variables. Who's the dependent variable and who's the independent variable. Now how do I recognize it? Observe carefully. When you see this entire equation, in this equation, there is dy by dx. There is dy by dx. Now it is a clear indication when there is dy by dx, it means y is the dependent variable, dy by dx, x is the independent variable. So from here we can clearly understand who is the dependent and who is the independent variable. But there is one more indication, and the other indication is more powerful than the first one. Who's the other indication? If you look at the entire equation very carefully, what are the terms are randomly scattered, wherever the terms are there, watch every single term, you will find there is a single y. In the entire equation, you will observe there is only one single y present and lot of terms of x, functions of x. See, sin 2x is there, see, tan x is there, but if you observe, there is only a single y. This y recognizes that the question belongs to dy by dx plus py is equal to q. We know that is the first type, dy by dx plus py equal to q. There is a second type, dx by dy plus p dash x is equal to q dash. So a particular question falls into type 1 or type 2. Who will decide it? Obviously dy by dx or dx by dy will decide. But from this term apart, there is another term which is more powerful in deciding whether the problem falls into type 1 or it falls into type 2. Watch the entire equation very carefully. If you observe, there is a single y and there are a lot of terms of x. Only one y is present and lot of terms of x are present. That means this type, this particular question definitely falls into dy by dx plus py is equal to q. It has to look like this. Dy by dx plus py is equal to q. There is a single y if you observe in this differential equation. In our question also there is a single y present. That is how I recognize that this problem has to fall in the type 1 type. Type 1 question, dy by dx plus py equal to q. Now, I have to arrange this equation according to the differential equation that I have already learned. This equation must be transformed into this part, this type. So, it tells me dy by dx is alone. See, there is no coefficient with dy by dx. dy by dx is a single term. So, if you observe this dy by dx, it is accompanied by what term here? Sin 2x. So, your first job is to remove this sin 2x from here. Get that sin 2x out of there. It can be easily done. Divide throughout by sin 2x. That means I can say this equation can now be written as dy by dx is equal to y upon sin 2x and then plus, if you remember, tan x can be written as sin x upon cos x. So I've written tan x as sin x upon cos x, and in the denominator sin 2x is going to come, and that sin 2x can be written as 2 sin x into cos x. I'll use the trigonometric formulas also. Now, I can clearly see sin x and sin x, this term is going to get cancelled. Further, dy by dx and the next term is py. So the term of y is also accompanied with dy by dx. dy by dx and py should be together. And q, which is only a function of x. Q is only a function of x. Only a term of x. It should be on the right hand side. P is also a function of x, but it is accompanied with y. So from these two terms, if you observe, this thing is only and only term of x. Everything is in terms of x, and this thing, if you observe, it is accompanied by a y. So dy by dx, dy by dx. Then I should have py. So p and y is the term, y is the dependent variable. In this equation, I can see y over here. So I'm going to get this term from the right hand side to left hand side. So I'm going to write it like this: dy by dx. Watch closely. Plus minus 1 upon sin 2x. And y. Look at my arrangement. What I have simply done, this entire term y upon sin 2x is taken on the left hand side. So definitely it's going to become minus sign. But my equation should look like dy by dx, then a plus sign, then p, then y. So this minus sign I have put it with 1 upon sine 2x. Then this looks like dy by dx plus, then this is p, then y is equal to, sine and sine has cancelled, cos and cos is going to become 1 upon 2 cos square x. So ultimately I can say this is dy by dx and then plus 1 upon sine, if you all remember, it is cosec 2x, and y is equal to 1 upon cos square is sec square x upon 2. So now if you observe, it clearly resembles dy by dx plus py is equal to q. So if I compare this dy by dx plus py equal to q with this equation, I can definitely say p is going to be minus of cosec 2x, p is going to be minus of cosec 2x, and q is going to be sec square x upon 2. So that's p and q. Now once I've got p and q, I already remember if I want to write the solution is given as dependent variable into the integrating factor is equal to integration of the right hand side of your equation into the integrating factor and then d of the independent variable and plus c. That's our formula. You have to memorize this formula. It says dependent variable into the integrating factor. Then integration of RHS into the integrating factor. D of the independent variable plus c. So to use this formula, what I need is the integrating factor. Integrating factor, again if you recall, is given by e raised to integration of p dx if your problem is of type 1, dy by dx plus py equal to q. If the problem is of type 1, dy by dx plus py equal to q, your integrating factor is e raised to integration of p dx. So for this, I will need integration of p dx. So that's my first step. I'll get integration of p dx first. Let's see what is p. So we know p is minus of cosec 2x. Let us write it here. Your integration must be very strong if you are solving differential equation. Many of the students are not knowing differential equation. The reason, they don't know integration very properly. So make sure that you do your 12th integration very seriously, very properly, so that this topic becomes more comfortable to you. Now, integration of p dx. I know p is minus of cosec 2x. So I'm going to write integration of minus cosec 2x dx. So minus n is a constant, goes out. If you remember integration of cosec x, I will write a formula. Integration of cosec x, there are two formulas. One of the formula, the big one, log of cosec x minus cot x. That's one of the formula. But my favorite one is log of tan x by 2. That's a simple and a very small formula for integration of cosec x. So whenever you are going to use integration of cosec x, instead of using the long formula, always make use of the short formula, log of tan x by 2. So it was for cosec x, integration of cosec x. Look at the formula, it contains x by 2. So if I am writing for cosec 2x, it will definitely contain x. So my answer would be minus log of tan x, and never ever forget to write the coefficient of x. Coefficient of x is 2, so I'm going to write 2 over here. So that's my integration of cosec x, or cosec 2x. So minus of log tan 2x upon 2. There is no need to write plus c at this moment. Plus c is accompanied at the end of the problem. So integration of p dx is done. Once integration of p dx is done, I can now get the integrating factor. So the integrating factor now becomes equal to e raised to integration of p dx. So e raised to integration of p dx is minus 1 by 2 log of tan x. Now observe carefully what things are going to happen over here. This can be written as e raised to log of tan x raised to minus 1 by 2, which can be written as e raised to log of 1 upon root tan x. Observe carefully what happened. Tan x raised to minus half. First of all, it has taken the denominator. A raised to minus n, 1 upon a raised to n. So that became 1 upon tan x raised to half. But tan x raised to half, it simply means root of tan x. So e raised to log of 1 upon root tan x. Further, I also know e raised to log. It will go and I will simply get 1 upon root tan x. E raised to log of x is only x. So that's my integrating factor. Now I can go further and get my solution. So once I know what is the integrating factor, now I'm going to get my solution. So observe carefully how to find the solution. We already know the formula. The formula is written over here. I'm going to make use of that formula. The formula says dependent variable. In our question, dy by dx when I've written, y becomes the dependent variable. So I'm going to write y. Let's write y into the integrating factor. So that's 1 upon root of tan x. So I'm going to write y upon root of tan x is equal to integration of the right hand side, which is q. So in our case, q is sec square x upon 2. So I'm going to write sec square x upon 2 into the integrating factor, which is 1 upon root tan x. So I'm going to write 1 upon root of tan x dx and plus initially I write c dash. I have told multiple number of times, know your integration very properly. Watch my previous videos of corollaries on integration. It will give you the detailed knowledge of the 3 different corollaries that you want to remember while solving integration. Over here also, obviously I have substitution available, but using substitution will take slight time to get the answer. Make sure you know your corollaries very well. If you observe carefully, tan x has derivative sec square x. Derivative of tan x we all know is sec square x. So if you remember, there is one corollary in integration that we have learned. It says like this: integration of f1 of x upon root of f of x dx. Now observe the corollary very carefully. What it is telling? f1 of x, that stands for derivative of the function, upon root of f of x. So f1 of x upon root of f of x. The answer is simply 2 root of f of x. So if you observe in your question, there is f of x. Tan x is your f of x. Derivative of tan x is sec square x. That is present here. This is f1 of x. 2 is a constant, can be taken outside the integration. So I can write y upon root of tan x is equal to 1 by 2 is taken outside the integration. Sec square x upon root of tan x. It exactly resembles your corollary that you have just now seen. It represents f1 of x upon root of f of x dx. So it is going to give me the answer. 1 upon 2 remains as it is. f1 of x upon root of f of x. Answer is 2 root f of x. So 2 root tan x plus c. Obviously the 2 and 2 will get cancelled and your final answer is going to look like y upon root of tan x is equal to root of tan x plus c. So that's the solution of the linear differential equation. I hope you have understood this well. Please continue.